let's go ahead and take a look at this and see how you guys did. 1 centimeter equals how many millimeters? 1 meter equals how many millimeters? 1,000, which is how many centimeters? 100. Love that metric system. 1 kilometer, how many meters? 1,000. All right. So there's our metric system there. Now let's take a look at our gallons, quarts, and whatnot. How many quarts in a gallon? 4. How many cups are in a quart? Ooh, I heard 2, 4, 6, and 8.
8.
No, wait, was it what?
Wait.
Okay, I want you to discuss with the people right around you. Come to a conclusion.
And then they eat the 2 cups. Wait, oh, it's a 2 cups. I remember.
Okay. Show me on your fingers how many cups are in a quart. See if we came to any better of a conclusion. Okay, so we're down to 4 and 8, and there's still a couple 6s hanging out up there. All right. So I heard some of you guys say gallon man. I used this, or this is what I learned, which I think you guys just have a nice little story for it. But in a gallon, we have quart, so 2 quarts and a half gallon. Okay, so 4 quarts in a gallon. In each quart, we have 2 pints.
Oh, the pints and food.
And there are 2 cups in each pint.
Where? No way. Oh, it's 4.
So it's 4.
Yep, I was right.
Last class I said something about like gallon king, and then
Where's the queen?
why are there 4 queens?
I don't know. Oh,
And something about 2 crowns for the princess.
No, it's cats. Cats.
Okay, that's better, because I was like, that princess is high maintenance. She needs 2 crowns. So whether you remember gallon maid or whatever that little tale is, this is what I used to remember it. So how many cups for the quart? 4. Also, if you go home and look at your quart measuring, the glass measuring cup thing that has a quart in it, there's 4 cups. If you guys don't use it very often. Okay. And then we are coming down to our English standard units. So how many inches are in a yard? 36 inches in a yard. Brendan, how many inches are there in a foot? Good. Okay. Now, how many feet are in a mile?
5,280.
9,280. I always thought that sounded like a nice number. Who figured out how many yards are in that?
1,760.
Good. And Brendan, how do you figure that out? Okay, how can we mathematically figure out, given the feet, how many yards there? Yeah, so we have 5,280 feet. There's 3 feet here to divide by 3 and get 1,760. Good, very good. Okay, you do need to have your conversions memorized. So it sounds like we need to work on a few of those. Just make sure you memorize those or refresh your memory. Probably these ones. Okay, so what I think of is just on a ruler, like the centimeter, there's 10, it's always like a unit of 10, so there's 10 millimeters in the centimeter, and then there's 100 centimeters, and it's like they keep adding on to 0. But you guys learned about King Henry drinking chocolate milk and dying. So King Henry died by drinking chocolate milk. Okay, now correct me if I'm saying this wrong, because I just learned this yesterday. This stands for our base unit, which is meters. And so each time you move down a step or up a step, you have to add on a 0. So if I'm going to go from meters to centimeters, then that's 1, 2, so that's 2 zeros, so 100 centimeters are in a meter.
Okay.
And if I want to go to millimeters, 1, 2, 3, that's 3 zeros, so 1,000 millimeters are in a meter.
Okay.
If I went from, so like this one, kilometer to meters, 1, 2, 3, so that's 3 zeros, so there's 1,000 meters in a kilometer.
Okay.
That's what I learned yesterday. So you can use this.
What if you were going like meters
Meters to where? Or meters to kilometers?
Yeah.
So same thing, so it's one, so here's kilometers, here's meters is my base unit. So there's 1, 2, 3 steps, so that's 1,000 meters in kilometers.
Okay.
Like 1,000 meters, millimeters in kilometers. Does that make sense? Raise your hand if you learned the chocolate milk thing. Okay. All right, so remembering this, we're now going to go ahead and go back to elementary school. Do you guys remember when you did ratios in elementary school? Did I pass this out to you? I feel like it was like good.
For reading, for reading.
It's new sitting up front, right? I have responsibility. Everything back.
English is easy and harder than math.
Go back and get ahead.
Alright, is there anyone that did not get the notes for today? Okay, so again, today's stuff is pretty simple. We're doing some review of elementary school and then a little bit with our new school. Alright, so here's again just a summary of some of the conversions here. So what we're talking about to start off with are ratios. And a ratio is just comparing two quantities. We usually write it either as that fraction or as the colon or using the word two. And they're typically written in the same unit. If they're in different units, you definitely need to write your units, but they're typically written in the same unit. So we're going to rewrite these so that they have the same unit and check out the ratio. So we want to convert these to be the same unit and then simplify from there. Now typically you want to go to the smaller unit because if I said 16 hours and put that in terms of days, that would be a decimal, and a decimal in fractions not equal to 4. So let's go ahead and convert our days to hours. So how do I convert 4 days to hours? What do I need to do?
Multiply 24 by 4.
Yeah, multiply by 24. Okay, so if I were to multiply this out, what's 4 times 24?
96.
96. And then over 16. So this is now both in hours. Can we simplify that?
Yes.
I like the thought of yes. What can we simplify that down to?
24 over 4.
24 over 4, okay?
Wait, I can go more.
24 over 4, can we simplify that?
Yes.
What does that simplify down to? 6. Now I'm going to leave it at 6 over 1 just because we're looking at specifically in terms of a ratio. So just to kind of say that it's 6 to 1. We're talking about hours. Okay, now let's talk about some variations of what we could have done with this. We multiplied by 24. Now we could have simplified first before multiplying. That way we wouldn't have such big numbers to work with. So I could have actually even simplified this fraction. 4 over 16, what does that reduce down to? 1 and 4. And then I could have reduced 24 and 4 and gotten pretty easily or pretty quickly over to the 6 to 1. Also, back in one of my science classes in high school, I want to say chemistry, I think we converted stuff. Something that my chemistry teacher taught me is that when you're trying to convert, so here I want to convert my days to hours. So I think in one day, I want to match up my units diagonally like this. In one day there are 24 hours. So if you're not quite sure, because every year I have students that are like, wait, do I multiply or do I divide by the value? So sometimes this is helpful. I want my units to match up on top and bottom, and I want this to be the final units that I would like to finish in. So I have in one day, it's 24 hours. Okay. So So let's go ahead and take a look at this guy. So we have yards and feet. I want to finish in feet. So in 1 yard, how many feet are there?
3.
3. Okay, so this is how I set it up. If you don't have to do it this way. If you know just to multiply by 3, that's perfectly fine. Again, I'm going to simplify to start off. Oh look, I can simplify my 8 and then 6. What does that reduce down to?
3 and 1.
3 and 1. So what do I have for my final answer?
9.
9 to 1, and let's just go ahead and throw on the fact that it's feet there. So the ratio is 9 to 1 feet. Now again, normally our fractions would simplify completely, but since we're talking about a ratio here, that's why I'm keeping that as the 6 over 1, or 9 over 1. I know that whatever this ratio is talking about, it's 6 times more than that value there. This is 9 times more. Maybe we're talking about the size of a fenced-in area. Maybe the length is 9 times bigger than the width. Okay, I want you guys to go try 3 and 4. Oh yes, we have decimals there.
Supposed to be 3 and 4.
3 and 4. Go ahead and check your answers with your shoulder partner real quick.
Draw. I'm pretty much just dancing.
Yeah. Once you check with your shoulder partner, check with someone in front or behind you.
Ow!
Oh, I did this slowly.
Yeah, I didn't do it.
I don't know if I did this. What'd you get?
I got 3 over 1. I think it's 10.
Well, I know you did.
Because you multiply by 0.1 outlier. Because you're getting bigger, so you go from, so you basically,
Yeah, because you're trying to.
because in milliliters you're getting centimeters, and numbers getting
Is this
smaller.
like these things that's heavy?
No, it's usually beginning.
This stuff is like really crazy, because I never really learned it like this.
80?
So like, I'm gonna guess.
You do it whatever way you like.
I only know how it is.
It helps speed it out so it's like for this where it's like 0.6 kilometers, but I'm trying to think of how many meters it is, and I know that meters is
So I
smaller
didn't
than
know.
there's a whole lot more. So it's not just 10 meters. It's probably more like 100 or 1,000. But you can at least get it down to that.
Because I know that if everyone down,
I learned this 1 year, I'm gonna
Okay, I just learned chocolate milk yesterday.
Oh.
Okay, let's go bring it back up front.
Or to the right, so like,
What did we get for our final answer for number 3?
3 over 1.
Oh, hold on, what'd you say?
3 over
3 over 1? Okay. 3 over 1, and we finished in meters, right?
Yes.
Alright, and then what do we get for our final answer for number 4?
40 over 3.
I think I heard 48.
40.
40.
40
Over
over
40
3.
over 3. And that finished in millimeters.
Oh, I did say.
Okay, so I'm gonna go. I am again going to show you using this way. You can use whatever method works for you. So I have kilometers. I know that 1 kilometer is how many meters? Good. So here's our base, which is meters. So 1, 2, 3. So 3 zeros. 1,000. So you could either reduce your 1,000 and 200, or you can multiply the 1,000 and the 0.6. There's 3 zeros, so I can move this 3 decimal places, which means that this would be 600. Does that make sense?
Yes.
So this is going to be the same thing as 600 over 200 meters, and that's what reduces down to 3. Or at this point, you could have slashed out your zeros, 1, 2, 1, 2. And then done 0.6 times 10 would be 6 over 2, which gives us 3. Okay, and then over here. So it's a little bit different because it's millimeters on top, so here's the bottom. So in 1 centimeter, how many millimeters is that? 10. There are 10 millimeters in a centimeter. So again, you could go ahead and multiply the 0.6 times the 10. So we have 80 on top. 0.6 times 10 would be 6, and then reducing that gives us the 40. Questions with those 4? Yes.
I did like 0.1 centimeters and then 1 millimeter. Is that the same thing?
0.1 centimeters is 1 millimeter. Yes, yes. Yep. You're just living on the edge of those decimals. That's fine. Brandon?
So I converted it into like centimeters.
Okay, so then what was your final fraction, Leah?
8 over 0.6.
So you want to simplify that. So guys, you should never finish with a decimal in your fraction. So you would want to convert that then. So you said what, 8 over 0.6? And this is the same thing as 8 over 6/10, which would be 8 multiplied by the reciprocal, and then reduce that. Okay, so just make sure your final answer doesn't have decimal in it, and then just make sure you have centimeters on the end for your units. But I would recommend, usually to avoid having to do this, always go to the smaller unit. So like between centimeters and millimeters is a smaller unit. So that's one. Yes.
So like, say if like either way they both be like easier. So like, would it matter which way you converted?
Nope. Either way is fine. Other questions with this? Okay. All right. So again, this is the ratio. Ratio is the comparison of 2 values. And the reason why this is important is because we build upon this with proportions. And when we have similar figures, we have at the sides of the same ratio, meaning that they're proportional. So let's recall what a proportion is. A proportion is an equation that states 2 ratios are equal. Okay, so this is where we have a fraction is equal to a fraction. That's a proportion. 2 ratios are equal, that creates a proportion. So just some properties of proportions. The first 2 we use pretty often. The last one we don't use quite as often. First of all, if we were to go about solving a proportion, so like for number 5, how do we go about solving that? What do we do? We cross multiply, right? So if I were to take this, my starting proportion here, and cross multiply, I'm just write this off the side, as a times y equals b times x. Okay, so these properties are just coming from a variation of using our cross multiplication. Okay. So our first property that we have here is that I can take my entire proportion and just flip it upside down. This is equivalent to b over a equals y over x. Okay, so I can just take the entire proportion and flip it upside down. I'm just going to write flip off to the side. Sometimes this is beneficial for us if our variable is in the denominator, we'd rather have it in the numerator. You can just take the whole thing and flip it upside down. Or maybe the numbers are easier to simplify for you, flip it upside down. But usually we cross multiply, it doesn't impact us as much. So where this comes from is that if you notice b is on top and the denominator, so if I were to divide both sides by a, and I want to get rid of my x, then I would have y over x equals b over a, y over x equals b over a. So that's where that comes from. This is an equation, so I can flip it back and forth. What allows me to flip it back and forth across these axes? Did you say the internet?
Reflexive.
Reflexive, good. Reflexive, no, not reflexive, sorry. Symmetric, good. So symmetric property is what lets me just rewrite this as this, right? So we already have that from before with algebra 1. Our symmetric property lets us just flip it back and forth. Okay, so here where I have b over a equals y over x, I just showed you that y over x equals b over a, that's the same thing. Okay, so our first property is just that you can flip the whole thing upside down. Our second property is that we can switch a diagonal. Okay, so I could say a over x equals b over y. So I'm going to say switch diagonal. And it doesn't matter which diagonal you switch. You can switch either one. You can switch both diagonals if you want. If I were to switch both diagonals, I get right back up to this. So the reason why that is allowed, again, if I go back to my cross multiplying, so I'm going to cross multiply. So notice here I have x's on the bottom, so if I just divide both sides by x, both sides by y, and I have a over x equals b over y. Okay, so again, these are just variations of how we could change our algebraic manipulation of the cross multiply. So first you can flip the whole thing upside down. Second, you could switch the diagonal, and you could switch either diagonal, you could switch both diagonals, whichever you prefer. Now our third one is not quite as obvious. Our third one is this. This is equivalent to a plus b over b equal to x plus y over y. A plus b over b equal to x plus y over y. Alright, so let's talk about where this comes from. How do we suddenly have a b on top on one side and a y on top on the other? Well, I take my original fraction here. And let's add 1 to both sides. Would you agree that this is still equal? Add the same amount to both sides. Now, if I wanted to combine this together, what do I have to do to combine a fraction with another number? If I wanted to do this, what do I have to do to combine those together? Get a common denominator. Yeah, we need it to have the same denominator. Okay? So I would multiply this by b over b. And I would multiply this by y over y. Are we all okay with that? Just going back to algebra 1. So this is really the same thing as saying, I'm going to save some space here. A over b plus b over b. X over y plus y over y. Now that they have the same denominator, now I can add them together. And how do we add fractions together? Let's say that I had this. Good, we add the top, bottom stays the same. It's not 17/9 to 17/3. Okay, so we have 2/3 of 5, 15/3 of 5, and 17/3 of 5. That's a lot of 5. Did you guys eat some pie this past week?
Yes.
I realized I forgot to eat pumpkin pie. What was I thinking? I had sweet potato pie, but I forgot pumpkin pie. No, it was good. It tasted almost like pumpkin pie. I feel like I need to make a pumpkin pie now. I was so disappointed in myself when I realized it. Okay, so we add together the tops. Denominator stays the same. So we have a plus b. Denominator stays the same. X plus y. Denominator stays the same. That's where this comes from. So it's really just adding 1 to both sides, and then it's been simplified. Alright, so again, the top two we use way more often than that third one, but it's still a property that you do need to know. And you will have questions where it's just straight up asking about the properties. Okay, so let's go take a look at solving these down here, 5, 6, and 7.
These properties and those.
No, they're just properties. We won't use them in a proof or anything, we just use them to solve. But honestly, a lot of times we just cross multiply and bypass those properties. Alright, so for number 5 here, we have x over 8 equals 5 over 20. You guys said we could cross multiply, right? So we get 20x equals 40, x equals 2. Now, we technically didn't need to cross multiply because my variable is already sitting on top. So I could just multiply by 8 on both sides, right? The inverse operation division is multiplication. And simplify from here. 5 times 8 is 40, 5 by 20. But it's fine to cross multiply, it's just you're actually doing one more step than is necessary. Alright, for number 6, again, we don't have to cross multiply. You can if you want to. When you're working with problems, work smarter, not harder. You don't have to always multiply everything out. Simplify first. Can I reduce 5 and 13? No. If I multiply both sides by 52. Instead of multiplying 52 and 5, can I reduce 52 and 13? Let's try.
Yeah, it's 4.
What is 13 times 2? 26 doubled? Yeah, it's 4. Good. So we have, this would then be 4 times 5. Just have 1 left at the bottom. So n is 20. Now, you don't have to go through and simplify all that. It's just when our numbers start to get pretty big, it's usually easier for us to simplify first before multiplying. But if you'd rather multiply than simplify, that's fine. But you can save yourself time doing that. Okay, questions on 5 or 6? Okay, so number 7, we cross multiply. We get 6y minus 7 equals 5y plus 4, right? Good, good. We have to multiply 6 times this entire thing. 6 times y minus 7. And we have to multiply 5 times this entire thing. That's the biggest mistake I see when we cross multiply, is that we neglect to distribute. Now, if you want to distribute, instead of writing it out and then distributing, that's fine. You can skip this middle step and just go straight to saying 6y minus 42 equals 5y plus 20. That's fine with me. But just don't forget to distribute. Okay, what do we get for our answer here?
62.
So if I were to take 62 and put it back into my fractions here, I should have that the left fraction simplifies to the same thing as the right fraction. They should simplify into the same thing. They may not start off the same thing, but they simplify. Okay, questions for that? Okay, so that was our review of Algebra 1. This is what we use from Algebra in our similar triangle students. Let's take a look at how this impacts us. Alright, so 2 polygons are similar, so let's talk about what it means to be similar. If their corresponding angles are congruent, and the corresponding sides are proportional. Okay, so a few things you want to take note of. Angles are congruent, go and circle that on your paper. That's the same as our congruent triangles, right? Congruent triangles on your figures, the angles were congruent. But what's different is that our corresponding sides are no longer congruent, but rather they are proportional. And proportional, let's just make a note, that means the same ratio. They simplify down to the same ratio. Our symbol that we use for similarity is just the little tilde, no equal sign underneath. So that indicates that 2 figures are similar. I think you guys already have letters for these, right? Yeah.
A, B, C, D, G.
What letter is this one?
G.
So they have told us that the 2 figures are similar. So what that means for us, if the 2 figures are similar, what we can say then is that angle A is congruent to angle G. So angle A is congruent to angle G. we have that angle B is congruent to angle B. We have angle C is congruent to angle O. And then we have angle D is congruent to angle N. Alright, so that's the same as what we had before for congruent figures. But now what's different is we also have the sides are proportional. So the sides have the same ratio. So we also know that side AB matches up with GE. So if I were to compare side AB, its measure, to side GE's measure, that ratio would be the same as if I compared side BC to EO. Right, I would compare BC to EO. Notice we're not saying that they're the same values of measure, but that their ratio of the sides simplifies to the same. And then likewise, I have CD matches up with OM. So if I compare CD's length to OM's length, it should reduce down to the same fraction. And finally, AD and GN. And GN doesn't match up. So AD compared to GN. So if I compare my ratios, so I compare the length of the sides, they should simplify down to the same thing when they are similar. Notice when I set up my ratios here, I went left to right, left to right, left to right, left to right. It does not matter which order you go in, just as long as you're consistent with it. Now, if they've already given you the similarity statement, then you want to follow this left to right. But if you're trying to prove that the triangles are similar, you aren't given the similarity statement, you can choose which order, just as long as you're consistent. It does not matter which side you start off with. Okay, so this is saying that the ratio of the sides is the same as this ratio, which is the same as this ratio, which is the same as this ratio. If the ratios are the same, we call that proportional. So this here, listing all of our sides are proportional, that's our statement of proportionality. So when we have two figures that are congruent, we know their angles are congruent, and we know their sides are proportional. Okay. So next class, so next class we'll be learning 3 ways to prove that the figures are congruent. Just like when we did congruent triangles, at first we had to have all 6 pieces were congruent, and then we learned those 5 shortcut ways. Here, similarly with our triangles, instead of having to show all the 6 pieces are the same, we're going to learn 3 shortcuts. We're going to learn those. Alright, so this one means to be a similar figure. Basically, it's the same shape, but different size. Okay, so angles are the same, but the side lengths are different. Alright, so then one more vocab word with this is our scale factor. Our scale factor is simply that ratio of the sides. Okay, so the ratio, the corresponding linear measurements of 2 similar figures. Oh, that's saying the ratio of the sides. Okay, I think you have stuff filled in for this as well.
Yes.
Yeah.
So it's A, then 15, B, 25.
And this is my right angle, right?
Yeah.
And then the ones
Is this X?
Yes.
Y.
6, Y, 10, 2, Z.
So, thank you. I'm sorry, what did you say?
Angle D, angle Y.
Oh, gotcha. And then these ones.
Yeah.
Why don't you do that?
Okay. So here they've given us that these 2 triangles are similar, and we can see that our angles are congruent. We've got that matching up. So what we should find is that our ratio of our sides are the same. If the figures are similar, they should be proportional, so the ratio of the sides are the same. Okay, so let's go ahead and list that out. I'm going to be comparing left to right, so AB matches up with XY, so we're going to compare the measure of AB to the measure of XY. And the measure of AB is 50. The measure of XY is 6. Alright, and then we're going to compare that to BC and YZ. BC is 25, YZ. And then AC matches up with XC. And AC is 20. And XZ is 8. Alright, so as we can see, our side lengths are not the same, but we should have that these are simplified to the same ratio. Alright, so let's check. 15 over 6, what does that reduce down to? 5 over 2. Alright, so those are both divisible by 3. But these are divisible by 5, what does that reduce down to? It's looking promising. What are these both divisible by? 4. 25 by 4 is 5. Oh, good. We should have indeed that these are the same because they told us that they're similar. Next class, though, we're going to have to check to see if they're the same as we first. I want you to see what the ratio is. So now that we know what our ratio of our sides are, now we can say our scale factor. So our scale factor of triangle ABC to triangle XYZ is 5 to 2. Now just make sure you're careful that when you write your ratio, your scale factor, that you make sure it matches up with the order. We did AB to XY, so we did triangle ABC to XY, so 5 to 2. If you would have written your statement the other way, you would have said 2 to 5. When they have the statement already written out for you, then you're just going to match that order. But if you're writing the statement, it doesn't matter which order you use, just as long as your numbers match. So our scale factor lets us know that this is essentially 2.5 times bigger than that. 5 to 2. 5 to 2 is, or 5 over 2, that would reduce down to 2.5. This is 2.5 times bigger than that. Okay. So again, with similar figures, we know our angles are congruent and the sides are proportional, meaning that they have the same ratio. And that ratio is our scale factor, which tells us how much bigger or smaller that figure is. Questions with any of this? A lot of vocab, but similar words or words that we've learned. Okay. So here it says are we polygons similar? If they are, write a similarity statement and give the scale factor. Okay. We've got the angles match up. Awesome. So let's just go ahead and list out those angles matching up. We've got angle H is congruent to angle R. Z is congruent to angle B. Angle E is congruent to angle L. Angle G is congruent to angle Q. Alright. So we have our angles are congruent. That's half the requirement. The other half is that our sides are proportional. Our sides have the same ratio. So we have to check. We don't know that it's similar. We have to check and see, are the sides proportional? Okay, so let's go ahead and compare. Now, as you're comparing, you want to make sure you're matching it properly. HG would go with RP because that's the 2 arc to the 3 arc. But usually what's a lot easier to do is just match up small with small, medium with medium, large with large. Okay, so let's go ahead and do that. Which side is our smallest side here?
E to G is L to Q.
Okay, so we're going to check E to G. G compared to LQ. And EG is 12, LQ is 8. And it is very important that you do label what it is that you're checking. Just like we labeled EG and LQ. All right, and then what's our medium length?
Are you just copying it like Are you just
So I'm looking at the numbers.
okay.
Yeah, sorry, we're looking at the numbers to the side. So what's our medium length?
D,
D, E, and P, L. Good. D and P, L, which would be 18 to 12. And you can see here why it's super important that you label. If you just said 12 to 8, 18 to 12, what 12 are you talking about? All right, and then our large side, they're the same, okay? So that's nice for us. We only have to check one set of numbers. So we have DH to PR. And that's going to be the same ratio as HG. to RQ. So since it's the same ratio, I'm just going to throw it in the same statement here. And that would be 24/60. Okay, so we have to check the ratio of every single set of sides. Right now the numbers look different. Let's see if they simplify the same. Don't automatically assume it. Alright, let's have these two rows check the 12 to 8. These two rows simplify the 18 to 12. And these two rows simplify the 24 to 16. Do you want to go ahead and do that? Alright, my EG row, what'd you guys get? 3/2. My DE rows, 3/2, it's looking good. HGDH rows, 3/2. Awesome. Okay, so since all of my angles are congruent, corresponding angles are congruent, my corresponding sides are proportional, meaning they have the same ratio, then I can say that the polygons are indeed similar. So yes, we have DEGH is similar, and make sure you have the letters matching up. PLQR. So triangles, we put the little triangle symbol. When we have figures larger than that, you don't need to, because you just have to list out all the letters. So we know it's a quadrilateral. And guys, it doesn't matter which letter you start with, just as long as you go in either a clockwise or counterclockwise motion. So it's fine if you said, let's say, GHDE or GEDH. But what I don't want to see is CGHE. Don't go crisscross. All right, you have to go around this. All right, and it says what's the scale factor? Scale factor. And we want the 3 to be first. And again, you can write 3/2, 3/2, or 3/2. 3. Yeah, either one of any of these is fine. Just as long as the 3 comes first, since that's a larger figure. So again, we have this is 1.5 times bigger than that, and this is 1.5 times smaller than that. Alright, now you need to make this next statement stand out to you. So whatever you need to do that. Highlighter, use a different colored pen, put a huge star next to it, something. This is a really important concept here. Alright, since the ratio of the sides of two similar triangles is the same as the ratio of their perimeters. So if I know that my ratio of the sides, so like for this, let's go back to triangles. Here my ratio of the sides, which is just my scale factor, is 5/2. The ratio of the perimeters is going to be 5/2. So if I were to add up the perimeters and compare them, I would get the same ratio of 5/2. This is beneficial for us because we can use that to help us solve for the perimeter of one of the smaller triangles if we only know the bigger triangle's perimeter. So ratio of the sides, same as the ratio of the perimeters. That'll sneak back up. It's a small concept, but important. Okay. So our last thing for today is our angle-angle similarity postulate. And this is one of our 3 shortcut ways to prove that triangles are similar. And this is specifically with triangles. So up until now, we've just been talking about what does it mean for figures to be congruent. Well, now with triangles, we have 3 shortcut ways. Just like with our congruent triangles, we have 5 shortcut ways. For our similarity triangles, or similar triangles, we have 3 shortcuts. So this is our first shortcut method, the angle-angle similarity postulate. Alright, so if 2 angles of one triangle are congruent to 2 of another triangle, then the triangles are similar. So if I have ABC, XYZ, and let's say that these are congruent and these are congruent. From just this information alone, I can make the statement that triangle ABC is similar to triangle XYZ. I don't have to have any other information. That's all that I need. Now, this is the one that we had talked about briefly in our congruent triangles unit. Notice it says angle-angle similarity. Why don't we have to say angle-angle-angle?
Because it just goes, if two angles here, there's have to agree, there's have to be.
Good. That's our third angle theorem. It says that if two of the corresponding angles are congruent, it automatically follows that that third angle is congruent. So, in having angle-angle, we know the third angle as well. All right, questions with that? Okay, so let's take a look at worksheet 1. We'll do some experiments together on this. So remember, a ratio is a comparison of two numbers. That's our fraction, or colon. A proportion is an actual equation. So we can use ratios to create an equation. That's what a proportion, that we have two fractions that are equal. Alright, I want you to go to number 15. Alright, we've already talked about how to do those top ones, those are pretty simple. 15 through 18 is usually the type of problems that give students trouble, so I'm going to go ahead and do this together. We've done, number 15. We've done some problems similar to this back with our triangles, talked about the ratio of their angles. So it's a similar concept here, but now we're dealing with sides. So it says the perimeter of a rectangle is 40 feet, and the ratio of the width to the length is 2 to 3. Find the length and the width. All right, so my perimeter is 40. And it says the ratio of the width to the length is 2 to 3. So I'm going to write width. Here's what I mean. So I know that whatever my sides are, it should simplify down to 2 to 3. So we had something similar to this with our triangles, talking about the ratio of the angles. What we do is we just say, okay, my width to length, this is width to length, is 2 to 3, so I'm going to call this 2x, call this 3x. 2x to 3x simplifies down to 2 to 3. Now I can use that to help me set up an equation for my perimeter. How do we find perimeter again?
Add both sides.
Good, add up the sides. So for this particular one, we would say 2x plus 3x plus 2x plus 3x. And what was my perimeter?
40.
Or you could say 2 times 2x and 2 times 3x, or you can just go and add it together and say 4x plus 6x, which together gives us 5x, which is 40. So what's our x value? 4. Now, did they ask for x? No, in fact, we created x. 4 is what each thing is getting multiplied by. So it asks for the length and the width. What is our length going to be then? 8. Careful. Length?
12.
12. Good. The 3 went with the length there. So I have 12 feet. Don't forget your units. We haven't had a whole lot of units so far this year. And then our width would be 8 feet. Okay, so that's our idea for that. All right, I want you to try number 16.
Do we lose points if we forget our units?
Yes. So please don't speak. Oops.
If we don't want us to forget them, we don't make it a requirement.
That would just mean that you never used it rather than you not forgetting it.
Okay, we just don't think so.
But then there's nothing to keep you accountable. Also, too, if you go to Home Depot and you're like, I need 8 of that. Like, 8 inches, 8 feet, 8 centimeters, 8 meters. How much do you want? 8. Then they'll just give you the largest amount, so you have to pay the most money.
8.
8 miles.
8 miles, that's a lot.
No, 8 there.
That's even more. Once you get your answers, go and check with someone nearby you to make sure you're on the right track. All right, how do we find the area of a rectangle?
Find the length.
Multiply, good. So we have 3x times 4x equals 192. And what's 3x times 4x? 12x squared. 12x squared. Guaranteed some of you are going to mess that up on your quiz. What? You're going to do that on your quiz? All right. What's 92 divided by 12? 12 goes to 19 once. With 7 left over, 12 goes into 72 6 times. And we get x equals
4.
plus or minus 4, but can we have a negative measure?
No.
So we're taking just our positive form. But what did they ask for? Length and width. Alright, so our length, what would our length be? 16 feet. And our width? 12 feet. It's actually just feet. Our area is square feet, but the lengths are individual feet. Alright, questions on that? Okay, so let's take a look at number 17. We've actually done this type of problem before. So here it says the measures of the angles in a triangle are the extended ratio 3 to 4 to 5. Extended ratio is just saying that instead of comparing two quantities, we're comparing more than two. Okay, so we have 3 angles, we're comparing 3 quantities. Find the measures of the angles. So still the same idea. We have extended ratio of 3 to 4 to 5, so 3x, 4x, 5x. Alright, what do we know about the angles of a triangle? They have to be 180. Alright, I want you to go ahead and solve for 17 then. Alright, what do we get for our x value? 15. And we go ahead to the back end. Now, this is in the ratio of 3 to 4 to 5, so when you list out your angles, go ahead and keep it in that same order. What would our first angle be?
45.
45 degrees, 60 degrees, and you can double check that you did it correctly by adding that back up to make sure it equals 1. Alright, questions with those ones? Let's take a look at number 19. So it says you're given an extended ratio that compares the lengths of the sides of the triangle. Find the length of each side. Okay, so again, they give us an extended ratio where we're comparing 3 quantities rather than just 2. we can use a ratio to set up an equation. I can use any ratio within here. I can compare AC to BC, or AC to AB, or BC to AB. Any of those, it doesn't matter because you have the ratios that are going to go with it. I'm going to go ahead and compare AC to BC. According to this, AC to BC is 2 to 1. Does everyone see how I set up that proportion there? Again, our ratios let us set up that equation. Okay. So now let's take a look at our picture. AC is 2x. BC is 4. Equals 2 over 1, which is 2. And then go ahead and solve. What do we get for x? X equals 4. You can either cross multiply or just multiply out your denominator. So x equals 4, but the directions don't say to find x. They ask for the length of each side. So it's 34. What is this side going to be? 80. And this? 80. Oh, so what type of triangle is that? Isosceles, which you wouldn't have realized from the very beginning. Alright, go ahead. I want you to now try 18 and 20.
Is this yours? Yeah. Okay, let me grab you.
And as always, go ahead and compare your answers to that.
It's language, 24, 60. That's for 20 to choose it. CC is 4, BA is 6, and AC is 4.
Oh, that's fine. We're still in use, isn't I think between 5 and 8, there's 2.
Alright, for number 18, what do we get for our angles?
24, 60, and 96.
24,
60.
96.
do we agree with that?
Yeah.
Alright. For number 20, what do we get for our x value? So we should have gotten that this was 6, this was 4.
Yes.
Yeah.
All right, go ahead and flip it over to the back side real quick.
Because,
I want you to fill in 23 through 26 real quick. So this is again just applying those properties. This is our starting one. How can I rewrite this to still be true? Notice what has changed here. Q and P have been flipped upside down, so what has to happen to your P?
flip it upside down.
Very good. So go ahead and fill in those four. That's again just the straight properties. Keep it going. Okay, so as you see on your assignment sheet, your homework is to finish worksheet 1, the problems that we did not get to, and then worksheet 2. So essentially, worksheet